Okay, grade 8, my apologies for posting this video late here on Monday night, but better late is never. No, better late than never. I guess that's the expression. So your first questions are all your vocabulary, and I gave them to you before, but anyway, we'll go through them again. So blank is the number of square units on a 2D object. Now, even though really it's not, we're going to call it area. Area is the number of square units on a 2D object. So if I think about this 2D object being a rectangle, and if I imagined it was 3 units this way, and 2 units this way, the number of square units would be 6. There'd be 1 square centimeter here, if these were centimeters, of course. There'd be 1 here, there'd be 1 here, 1 here, 1 here, and 1 here. So therefore, the area of that 2D rectangle would be 6 square centimeters. Now the next one, question 2, says blank is a flattened 2D version of a 3D shape. The answer for that one is a net. I think the order might be different here, so just find the definition of that, a net. So for example, if we have that rectangular prism, and we were to break it down like we would break down a box if we were recycling it, we could break it down something like this, and this is called the net. This is called the net here. Okay, just breaking down a 3D object to show all of its faces flattened. The third one says a blank is a 3D shape with equal base and top. We call that a right prism, a right prism. And basically what that means is if we take any, like a cylinder, or a triangular prism, or a rectangular prism, or a cube, the sides of these prisms are all at what we call 90-degree angles. They're perpendicular to the base. So all of them are perpendicular, which means that's where the right comes in. And a prism is just a three-dimensional shape. So the top and the bottom in this particular cylinder are parallel to each other, and the base is at 90 degrees. The top and the bottom of this one, if it was to draw it in here, would be perpendicular or parallel to each other. And the top and the bottom of this one would be parallel, and the top and the bottom in this one would be parallel. So if they're parallel and the sides go up at 90 degrees, they're called a right prism. The definition is not so good in that one, but the answer is right prism. Question 4 says a blank is a prism with 3 faces. There's only one of them that we have that's 3 faces, and that's a cylinder. A cylinder. Now technically the textbook also says it might just have 2 faces, this one here and this one here, but if we draw the net, there's the top of the cylinder, there's the side, and there's the bottom. So we really can consider it, when we look at the net, as having 3 faces. Question 5 is a blank is a side of a 3D shape. We call that a face. So again, if we go back to my cylinder, this is called a face. The bottom would be called a face, and the side here would be called a face as well. 3 faces. And blank is the amount of square units on a 3D object. It's really technically area as well, and so is the other one, surface or surface area. Both are the same, but we just wanted to differentiate between the difference with a 3D object. So if I'm saying calculate the surface area, usually when we do it in a textbook, we mean calculate the area of each face and add them all together. Okay, the surface of a 3D object. All right, your next question is your formulas. So the first one's pi r squared, and that is the area of a circle, pi r squared. Pi d is the circumference of a circle, or the perimeter of a circle. Base times height divided by 2 is the area of a triangle. Length times width is the area of a rectangle. Just because I want to get it out of the way. Surface area of a cylinder is down here, so I'm just going to put that one down here so it's out of the way. Side squared is the area of a square. 2 base times height plus length times width times height is the surface area of a triangular prism. Don't have to move that very far. Surface area of a cube is 6s squared. If I scroll down just a little bit here, oh, hold on, what's going on here? I think I'm missing some of them. No, it's right here. The surface area of a rectangular prism is that. And finally, the radius of a circle is half of the diameter. So if you want to press pause and copy them down, you can. Those are the formulas you need to know. Question 7 is a grade 7 question. It says, what is the perimeter and area of this? So for the area of a triangle, the first thing you're going to do is you're going to write your formula. Area equals base times height. Then you're going to substitute. So the base is 10 and the height is 3. So for that, we're going to put 10 for the base and 3 for the height. And we're going to go divided by 2. Then we're going to go 30 divided by 2. And we're going to say the area is 15 square meters. Okay, that's for area. For your perimeter, now technically there is no formula, but we're going to make up one. One side plus a different side plus a third side And we'll just treat this as 10 for the first side, 8 for the second, and 8 for the third. Will mean your perimeter is 26 meters. Now notice for area, we're dealing with square units here. And for perimeter, we're just dealing with meters. Because perimeter is really just a distance unit. And meters are distance units. And area, as we learned before, is the number of square units that fit inside a shape. Question 8, what's the perimeter and area of this? So our area formula, we're going to write that area equals pi multiplied by the radius squared. We're going to treat pi as 3 for our test, just because it's easy to do without a calculator. The radius is right there, which is 8. So 3 times 64 would be your, because you have to simplify the exponents before you do your multiplication. And 3 times 64 would be 192, and therefore 192 meters squared. Your circumference formula is pi multiplied by diameter. So you'd have 3 for pi, and your diameter is really, since it's only gave you the radius, you have to kind of extend that, because the radius is, or diameter is really 2 radiuses, so it's really 16. And 3 times 60 is 48. So therefore, the circumference of the distance around that circle would be 48 meters. Question 9 says, what is the perimeter and area of this shape? So again, we're going to use area equals length times width. Now notice when we do that, we don't use the multiplication sign, we just put LW. Kind of like if we put 2x, that means 2 multiplied by x. We don't put a sign in between them, but we know that when a number and a variable are next to each other, just like a variable next to a variable, we can infer that it is multiplication. So the length of this rectangle is 8, and the width is 5, so we're going to go 8 times 5. Again, no multiplication symbols, just number next to another number in brackets. And therefore, 40 meters squared is your area. For perimeter, we really have the distance around. It's going to be 2 of these measurements here, 2 lengths. So we have 2 lengths to make up the perimeter, and 2 of these, which is and 2 widths. So altogether, we'd have 2 8s that make up our perimeter, and we'd have 2 5s that make up our perimeter. So our 2 lengths are 16, our 2 widths are 10. So therefore, our distance around the whole shape, or aka the perimeter, would be 26 meters. Question 10, what's the area and perimeter of this one? So our area formula is going to be side squared, just like we did with Pythagoras. Our side length is 10, so we're going to put 10 in brackets, and we're going to put a square exponent outside the bracket. That means 10 multiplied by itself twice. So 10 squared is 100, and therefore our area is 100 square meters. Perimeter is the distance around. So if we think about the distance around, we really have 4 side lengths, 4 10s. We have 4 multiplied, oh, I don't need a bracket for that. We have 4 multiplied by the side length, or 4 sides of 10, which means the perimeter of this circle, or square, excuse me, is 40 meters. The next question says, draw the net for this particular triangular prism and place the areas inside. So what we're going to do here is I'm going to extend this over here, and I'm going to draw my standard net for a triangular prism. So I'm going to break it into 3 rectangles, is what a triangular prism would have, and at the end we're going to have 2 triangles. This one we're going to call the bottom. This one we're going to call side 1. Doesn't matter what we call it, side 2. This is going to be the front. We'll put the front over here. The front triangle, and we'll put the back triangle. It doesn't really matter what you call it, just as long as you know that they're different. That's fine. So the bottom is really this measurement here and this measurement here. Because if I see the rectangle here, there it is kind of sitting right there. So it's 8 by 5, which means it has an area of 40 meters squared. I'm going to circle that. This one here is, we can call this one side 1. It really doesn't matter. But this rectangle right here is side 1, and it is 8 by 3. So it has an area of 24 meters squared. I'm going to circle that. And then the back one that we can't see is over here. It's a 4 by 8, so I'm going to put an 8 here and a 4 here. And it has an area of 32 meters squared. So our 3 rectangles, we have to kind of, it's hard to see it when it's in the 3D shape, but it's easier to see it when we break it down into a net. And then this front here, this one right here, that front right there is a base of 5. So our formula for the front and back would be base times height divided by 2. Be 5 times 2 divided by 2, which is 10 divided by 2, which means this triangle has an area of 5 meters squared, and so does this one over here, because they're identical, right? So therefore, if I was to use that first question, it says draw the face and get the total surface area by adding them together, I would then have 40 plus 32 plus 24, so that would be 72, 82, 92, 96, 106 square meters. If I add all of these faces together, the total surface area, would be 106 meters squared. Okay, let me just drag this down here again. Oh, that's not what I want to do. Okay, look at that. Isn't that cool? So the second says write a formula to get the area of the triangular prism. So for this one, we have to think about what that net is showing us. So the net really has two triangles and three rectangles. So it's really two triangles and three rectangles and make up the total surface of a Toblerone bar or a triangular prism. So two triangles would be 2 base times heights divided by 2. And since all three rectangles are different dimensions, I'm going to go one rectangle and two rectangles and three rectangles. I'm just going to separate them by adding them, three of them together. So for our triangle, we have two that are, again, our base here is 5 times 2. So we're going to get 2 that are 5 multiplied by 2 divided by 2. And we can call this one 1. I suppose the bottom could be 1. So it's 5 by 8. And we could do this one over here, which is 8 by 3, or 3 by 8, doesn't matter which way. And we have the other one at the other side, which is 4 by 8. And all of those together will add up to be the surface area of the triangular prism. So we have two that are 5 each, and we have 40, and we have 24, and we have 32. So we have 10 and 40 and 24 and 32, which is 106 square meters if I add them all correctly. Okay, that's the same answer as we got in the first one, just using a formula and substituting your data. Question 12 is a cube, and it gives you a side length of 3. So the first thing it asks us to do is draw a net. So if we broke down a cube into a net, we would have 6 identical faces, because a cube is really just 6 square faces added together. Each of these, since it's 3 by 3, each of these faces would have an area of 9 square meters. So if I replicated that, then we would have that looking there. So if we added 9 meters squared plus 9 meters squared 6 times, we'd have a total surface area of 54 meters squared equals the surface area. Now the second question says to do the same thing but use a formula. So since surface or side squared is the area for one square face and we have 6 of them, we're going to take that formula of side squared for the area of one square and multiply it by 6. Now this is technically a coefficient, so we wouldn't want to express it as this, because we don't want to put our coefficients behind our variables. Coefficients always go in front. So we're going to go 6s squared. We're going to go 6 and substitute the side length, or the edge length, which is 3. We're going to go 6 multiplied by 9. And that's going to give us the same answer as we got before, which is 54 square meters. A lot easier than drawing the net and figuring it out just to substitute your data. But of course, the net works, and it lets you see the prism in its with all its faces. Next question is your cylinder. Okay, so we have this cylinder here. It says draw a net. So before, remember we did with the piece of paper, we have a circle on the top and we have a circle on the bottom. And if you take that cylinder and you think of it as a piece of paper and cut it open, it actually became a rectangular prism. Now this is really hard to envision, but this distance right here, if I was to tilt this rectangle back down and put this one back up and make the cylinder again, this distance right here is the exact same measurement as the circumference of the circle, okay? And this measurement right here is the exact same measurement as the height of the prism, right, if I was to put that back together. So since this is actually the circumference, as the formula for circumference is pi d, what we use instead of the length of that rectangle, we're going to call it the pi d of the rectangle. And instead of the width of the rectangle, we're going to call it the height of the rectangle. And since the rectangle's formula is length times width, we're going to actually say pi d multiplied by h. And that's going to be the formula we use for that particular part. And over here, we're going to put pi r squared, and we're going to put pi r squared. So to get the full surface area of that particular prism, we're going to have those measurements. So for the first one, pi r squared, we're going to treat pi as 3. So 3 multiplied by the radius, which is given to me there, which is 10, squared will be 3 multiplied by 100. I have to do exponents first. And I have 300 meters squared is the area of that top circle. So I can put 300 in there and circle it. The bottom circle will also be 300. And then I'm just going to take my formula, which is pi d, which I said was the same measurement as the circumference. So therefore, it's because pi dh, or pi d and c is the same thing, and h. And I'm going to substitute 3 for pi. My diameter will actually be not 10, but 20, because it's double the radius. And the height is right here, which is 8. So I have 3 times 20 times 8, which is 60 times 8, which is 480 meters squared. So if I add all those up, I get a total surface area of 1,080 meters squared. Okay, that's using the net to solve the question. If I go and use my formula, remember I told you before this is a pi r squared and this is a pi r squared, so we have 2 circles and a rectangle. So those 2 circles are going to be 2 pi r squareds, and we have this rectangle, which is not length times width, but rather pi d times h, and that will be the formula we use for the surface area. So we have 3 times the radius squared, which is 10 squared, and we have 3 multiplied by the diameter, which is 20, multiplied by the height, which is 8. And when we simplify that all out, we have a total surface area of 1,080 meters squared. Now make sure here, right here at this particular part, make sure you do your exponents first, because bed mass, right? Remember, bed mass has brackets which aren't there. Those are multiplication brackets, not brackets like this, like 2 plus 1 multiplied by 3. That's brackets, but that doesn't exist in this one. Our E is our exponents, which means I have to do it first before I do my multiplication, and you would get the answer 1080 meters squared. And the last one of our thing is a rectangular prism. It says draw a net for this particular one. So I'm going to actually shrink this one down. This is quite big on my board here. So there it is. I'm going to draw my net. Now when you draw your net, remember a rectangular prism has 6 faces. So I'm going to make them like this. This would be the bottom. And if that's the bottom, then this would be the left and the right. This would be the front, actually, if you can envision it. And this would be the back. And if I fold it back up, this would be the top. So if you imagine folding that box back up into this shape here, this is what it would kind of look like if it was broken down. So the bottom, I can see my measurements there for the bottom rectangle, which is 10 and 6. So I'm going to put 10 and 6 in here. And my area of that bottom rectangle is length times width, so it's 60. The front, which is right here, is this one times this one. And since this one doesn't have a number, I have to go over here to find it, which is 5, right? So the front is going to be 10 multiplied by 5, which is 50. And the bottom and the top are the same, so I can put a 60 in here. And the front and the back are the same, so I'm going to put a 50 in there. And the last one I need to figure out is this right and left one. And there is the right, which is 6 by 5. 6 by 5, which means this has an area of 30. And my left is identical, so I'll put 30 over there. And then all I have to do is add them together. So 60 and 60 is 120. That's 220. That's 250. That's 280. So the surface area is 280 meters squared. Okay. Now if I use a formula, since the front and back are the same, and they're all rectangles, every one of them, I'm going to have 2 rectangles that make up the front and back, so we call it 2LW, and you can put an FB there, you can put a 1, 2, it doesn't matter. I'm just going to put 2LW right now. 2LW plus 2LW. So really, this is 2 rectangles that make up a front and a back, or a side, and a left and a right. These are 2 other ones and 2 other ones. So here I'm going to differentiate. I'm going to put FB for front, back. I'm going to put TB for top, bottom. I'm going to put LR for left and right. So we have 2 that are 10 by 6s. And we have 2 that are, oh, no, that's 10 by 6. That's the front and back. Oops, I got the wrong one there. So that should be, the front and back are 2 that are 10 by 5. And we have 2 that are 10 by 6. And we have 2 that are 6 by 5. Those left and right ones. There they are there, 6 by 5. So normally I would multiply 2 by 10 by 5 and do the 2 by 10 first, but I'm going to actually do this first, even though it doesn't impact the answer. It allows me to see that I have 2 that are 50, 2 that are 60, and 2 that are 30. And then I'm going to go ahead and simplify that to 100 and 120 and 60. And when I add them all up, I get 280 meters squared as my surface area. Okay, 20 minutes exactly. That's not so bad. Hopefully you got all the answers for this. And your test is on Wednesday, so good luck with that. The test will not be any different than this. It's just going to have different numbers instead.